We're going to do a quiz on the greenhouse effect. So if what you're going to find at your table is a piece of paper that you can write your answers on, and it's a team sport. So please join in with a table that has the piece of paper. On the other side is constituent comments. We are reusing paper here. And if you want an up-to-date letter to Congress, you can go to the CCL table, the Citizens Climate Lobby table over there. And so this is what you're going to write your answers on. It's going to be lightning quiz. There also on your table is a small, these small handouts which have some information, all the information that I have. There's 6 of them on a table. And they have a little bit of information about Missoula Citizens Climate Lobby Chapter starting. Paul Hawken, Draw It Down, is a great book. And so skepticalscience.org and Carbon Tracker, and then the City of Bozeman Sustainability Office, because I have some handouts from them on energy efficiency that are really great. They just hot off the presses. So that's when we get into solutions. And also there's some information from Citizens Climate Lobby on a type of carbon pricing, and that's also on the table if you want to look at that. So now you're going to have somebody who's going to write down your answers. So turn your paper over to the blank side, and you're going to have somebody who's going to write down with a crayon or pen, whatever you have. And it's going to be really fast so that we don't, so it's more like a test of what you already know. We're not going to try to figure anything out. So this is Science and Solutions, and I am not a scientist, and I'm not an economist. So it's going to be hopefully a little bit easier to understand than it might be. You know, some people, it's hard to sit in an academic situation when you're not in that field. So maybe it'll be helpful. And my background is in teaching students with disabilities, so I try to make things simple. But it might not be, who knows. And I left that job, my job working with people with disabilities in 2011 to work on climate change. I just felt like it was so important. And then Citizens Climate Lobby found me, and I'm a volunteer for them, as are most of the people involved in that group. So let's start with a quiz.
It keeps us awake though.
Okay. Okay. So, how does carbon dioxide warm the earth? A, sunlight warms CO2 in the atmosphere, which releases it to the earth, the heat to the earth. Sunlight goes through the atmosphere, heats the earth. That heat rises, some is absorbed by CO2 and re-released in any direction, including earth. Or C, CO2 acts as a blanket, building up a barrier to escaping heat from animals and volcanoes. Okay, lightning.
C.
Get together.
I have no idea.
B. Sunlight goes through the atmosphere, heats the earth. Then, I can move this around. No. Heats the earth, and then at night when the air is cooler than the earth, it will rise, and some of that heat will hit a greenhouse gas molecule, which will reflect that down to the earth, or maybe it'll go out to space, or who knows where it's going to go. The interesting thing is that it's exactly what happens in your car in the summer when you have the windows rolled up. So you have the sunlight coming down through the window, and it hits the seat, it warms the seat, and if you sit on it, you know how hot it can get. And then that energy, some of it's left in the seat, but it comes out as a lower energy infrared that will cannot get back out. it cannot get back out the window or the roof or anything. It can't get back out, so it just heats the car up incredibly quickly. So let's unpack that a little bit. The sunlight and infrared are both types of electromagnetic energy, just different wavelengths. And I love this slide because it shows you how long, like a radio wave is as long as a person, a gamma ray is as big as an atomic nuclei. They're all electromagnetic, but they have different personalities. Okay, they interact with matter differently, and matter has different personalities too. So when you combine the sunlight with matter, what happens? That's what we're going to try to find out. It's kind of like dating or something. You have somebody who's on the same wavelength, or you don't have somebody on the same wavelength. It's just like energy and matter. Like some works, some doesn't. So why does sunlight go through CO2 and the rest of the glass and the atmosphere, and infrared gets caught in the CO2? So let's look at that. Why just sunlight? Because CO2 is a gas and symmetrical, because sunlight has an attitude, or because CO2 is clear and asymmetrical. Okay, get a couple minutes, seconds. All right, let's see. Because CO2 is clear and asymmetrical. So sunlight is in the one range of that whole range we saw before, and it's in the range called visible, and it has and it reacts to molecules of color. Who knew, right? So that's why it can go through. It doesn't react with clear molecules or so glass or atmosphere. It just goes right through, is transmitted. All of those wavelengths will reflect off of white. All of those wavelengths will go into black and heat it up. And then individual, like red, is because everything else is absorbed and the red is reflected out to your eye. So we're going to just move on from that. So it interacts with colored matter. So what about infrared energy and CO2? Well, how does infrared energy interact with CO2 and other greenhouse gases too have the same properties? A, CO2 is asymmetrical and dances like Frankenstein. B, CO2 spins like a top. C, infrared energy splits off an electron from CO2's outer electron shell. What do you think? All right, so CO2 is asymmetrical and dances like Frankenstein. Water actually spins like a top when it's hit by energy, not infrared, microwave energy. And infrared splits off an electron from like outer shells for like X-rays. X-rays will split off an electron. So you want to see the Frankenstein dance? Okay, CO2 goes like this. It also can do the tango. Well, that's not exactly tango, but for a molecule, that's tango. Okay, where are we? I do have a joke, but I don't think I'm going to do it. You want the joke? Yeah. Okay. Carbon has 6 protons, usually 6 neutrons, 6 electrons, and 6 morons. Who says climate change is so funny? So how much CO2 is in the atmosphere? A, 30%, 29% oxygen, 30% hydrogen, 1% everything else. B, 71% oxygen, 18% carbon dioxide, 10% nitrogen, and 1% everything else. Or C, 98% nitrogen, 21% oxygen, and 1% everything else. I heard some C's, and you are correct. Yes. So basically, there is very, very little CO2 in the atmosphere. And it's measured, it's so little that it's measured in parts per million. So very, very little in the atmosphere.
What's the current parts of it?
Well, that's the next question.
Oh.
Yeah, I mean, we're coming to that. We're coming to that. So it doesn't take very much to make a huge, huge difference. Whoops. In temperature. And in the last 800,000 years, there have been 8 cycles. You've heard about all the controversy about the natural cycles. Well, yeah, there are natural cycles. And this is just one in the last 800,000 years. In the 4.6 billion that we've been, the Earth has been around, it's been a lot different. But it's been kind of in a pattern. If you count, there's 8 of those patterns between, that's basically between a glacial period, which is at the bottom, and the interglacial on the top. So what's the difference in carbon dioxide? Remember 2 numbers, 180 and 280. That's the whole difference between a paradise and ice, is the way I like to say it. I mean, that's incredible to me that 100 molecules in a million of the atmosphere make that much difference, but it does. Those cycles are started by the way the Earth is in relation to the sun. So we can be closer to the sun, we might be farther from the sun, the Earth might be tilting it back and forth. So that's how those cycles start, but it is carbon dioxide that does the heavy lifting. But anyway, does anybody know what those cycles are called? Write it down. Anybody? Okay. Milankovitch Cycles. All right. Anybody get that one?
No.
All righty. But those just start the whole process. It's carbon dioxide which really changes the temperature, which really adds up. It's like rolling up the window. If you add more carbon dioxide, it's like rolling down the window when you're releasing carbon dioxide, and it goes to space. We have a nice energy balance: energy in, energy out. But there are those little changes from glacial to interglacial. Well, right now, what is the CO2 concentration today? Whoa, we're up to around 410. Now, if you look at where 280 and 410 goes, that's 130 parts per million. Okay, so that's more than it has changed in the last 800,000 years. And there's a gap because it takes a while to catch up, for the Earth to catch up to that whole heat thing. And look at where we're headed. I mean, when somebody says, well, that's natural, hello, that's natural. That's not. Totally, the rapidity of it all is just astounding. So one reason that CO2 is so powerful is that it stays up there for like hundreds of years. But that's pretty complicated. I'm not going to go into it too much. But water, on the other hand, just goes up for in its cycle goes up for like 2 weeks and is back down. So if you've got something that's staying up, it's accumulating, and that's the big problem. Alrighty.
410 parts per million.
It's 410. Oh, give or take. Well, we're going to get to that too. You've got all the great questions. So
He started AERO.
Oh, okay. Okay, well, that's why. That's why he's a smart guy. So, anybody have, well, you don't have to do this part, but there is a lot of different kinds of molecules that have that same kind of structure where they can vibrate and then release energy like CO2 does. How's this one? Hydrochlorofluorocarbons. All right? And they are actually 1,000 to 9,000 times more potent than CO2, and they're in refrigerants. And so there's more to worry about than CO2, but CO2 is actually very worrisome in its own right. And because it is, the concentration's rising, because it accumulates. So here, why is that, you see the little red part that's going, ooh, what is that why does it fluctuate seasonally? A, because the northern hemisphere has more land and more plants, which start taking up CO2 in the late spring and stop taking it in the fall, or B, because the southern hemisphere has more ocean and it releases more CO2 in their summer when the ocean is warmer. Mostly because the northern hemisphere has more land, and it is, the plants actually do that, take up, I mean, that's how powerful the biosphere is. The biosphere really influences Earth. So concentrations are measured in, what did we parts per million, excellent, parts per million. So, but emissions and sinks, so while taking up that carbon dioxide, are measured in A, gigatons, B, billions of tons, or C, petrograms. Aha, trick question. All of the above. And they are all equal. So everybody's right.
Okay. Yay.
Everybody's right? So gigatons, they're all equal. So when you see something like that and you're trying, whoa, what is that? They're all the same. So I just want to get that out there. So here's a stylized version. This is like from like maybe 10 years ago or something, about the major natural sources of emissions and sink. So you've got the air-land cycle and the ocean-air cycle. How many gigatons do humans emit every year by burning fossil fuels, deforestation, agriculture, and making cement? You're getting them all right. You're getting this hat, I think. I don't know. Anyway, 40. It used to, so back then it was like, just a few years ago, it was the 29. Oops, 29. It's going up every year. But hopefully it's stabilized now. Our emissions, like a couple years ago, were pretty flat from last year. But remember, that's 29 on to 30 on to 40. I mean, it's accumulating. And this is just a better picture of what's really going on. But we're not going to spend time on that because this is scary stuff. So last week, the Intergovernmental Panel on Climate Change, IPCC, came out with a special report that says we really need to limit our emissions because terrible things are going to happen. So the difference between limiting our emissions and getting to a point of temperature that's 1.5 degrees centigrade, which is 2.7 degrees Fahrenheit, and 2 degrees centigrade is incredible, the difference. And so they come up with a way to kind of quantify. So they use a term called the carbon budget, and it's the amount of CO2 that human activity can emit and still hold warming to a certain amount of warming. And again, the fact that we're probably not going to be we're going to overshoot that probably, because what they're saying is 120 gigatons is all we have left that we can emit. And then other studies have said, well, it's 420. But if you're dividing that by 40 of our emissions every year, that's like 3 years or 10 years. That is not a long time. So they're suggesting and saying that we're going to have to draw down, sequester, take in carbon dioxide, which we heard about a lot today. And that the summary said, well, it's going to be closer to 100 gigatons we have to draw down. The actual report says closer to 1,000. So luckily, there are tons of ways to do it. And this book by Paul Hawken has 100 different ways to draw down or avoid carbon emissions. So it's what we need right now. Can I take questions at the end? Good. And all these different ways, they think that we could really, and the plausible scenario is the most conservative one, we could take down over 1,000 gigatons from the atmosphere by 2050. And they did a fabulous job. They got people from all over the world to work on this. Think about all these ways that you can lower emissions, quantify it by the emissions it would reduce, the cost, and other cost savings. So it's just a fabulous book. However, I bet Miguel would say, well, I mean, it has some things in there that might not be good, like the biochar that he mentioned or whatever. I don't know if they have taken everything into account, but they've taken a lot, and I think it's a great starting point. For instance, they said in the food sector, and you guys have already heard a lot of this already, but in the food sector, you could reduce CO2 by 322 gigatons by 2050 with just all the kinds of great things that they've talked about today. In the energy sector by 247 gigatons. So now you kind of know what a gigaton is a little bit. You have a little feeling for it maybe. You know, this is good. But as he also said, we need this to go faster. We need the political and social will to make this happen. And we need to act so fast, like at 3 years or 10, we need to act so fast. And I'm with this group that thinks that to do this, we really need to act on a federal level. It's great for, I mean, everybody has to do individual things too, but we have to work on a federal level. We need bipartisan support. We have to get this through Congress. There are other ways to do things, for instance, at an executive level, but then you have regulations or whatever, and then it changes, and then they take them all away. Legislation is much more robust and lasts longer. And also there's a judicial way to do it, which our Children's Trust is working on a lawsuit right now that is hoping, Monday it's supposed to go through and get into federal court. So there's other ways, but this is one way to work on a really broad national level. And the policy really needs to be economy-wide. There are lots of solutions out there, but we need something that really pushes everything. And we think that is carbon pricing. So carbon pricing is something you may never have heard of, but economists love it. And basically what it does is make fossil fuels more expensive. And you think, oh, that's going to pass Congress? Oh, yeah, right. Yeah. Who are you anyway? But we're saying that, yes, it could. But let's get to that a little bit later. Right now, why does it work so well? Well, people every single person here, they don't need to know about climate change. They don't need to know about anything. All they need to do is see a price, and that price is going to indicate how much carbon it has in it. And they're going to go for the cheaper one that was made with renewables, or that they figured out a more economical way or efficient way to truck their stuff somewhere. Or there's so many innovations that will happen when the cost of fossil fuels goes up. People are going to be hit equally. It's going to be through the economy. It's not going to be just power or transportation or industry. It will hit everybody. So everybody in your same industry is going to be hit, and they're all going to be looking for innovation. So it's incredibly powerful. The other thing is it makes us all accountable for our pollution. It puts that pollution is costing society so many billions, trillions of dollars. And if you put that cost into the fuel, you get to see all the pollution. You can see the cost of that pollution. And Canada, last week, I think, all this stuff happened last week. Maybe it's a couple weeks. Canada just implemented a countrywide carbon tax, carbon fee and dividend. And there you go. He's talking about the accountability piece. We're going to place a price on carbon that causes climate change from coast to coast. So we think that we, meaning Citizens Climate Lobby, who I think is fabulous, thinks that the best first step, so there's a lot of different kinds of carbon taxes. And one of the things that you look at in a carbon tax is where do they put the carbon tax into the fuel, right? So one place you can put it in is at the very beginning when it comes out of the ground. And you'll make it more expensive there, and then it'll get passed down to everything. Or you could put it on the piece of gum and the carbon content of the piece of gum. So, like, which one's easier? When it comes out of the ground, you're going to hit everything. You don't have to figure a lot out. It's just based on the carbon content of the fuel. Then the other thing the other thing about you want to look at, I'm going to back up actually. So the other thing you want to look at is what is it placed on? Is it placed on CO2 only, or is it placed on any kind of greenhouse gas or more kinds of greenhouse gas? And so there are proposals out there to just tax carbon carbon dioxide, versus ours would suggest putting the tax on different kinds of, like that, halo, fluoro, chloro, whatever. The other huge thing is what do you do with the money? Because it gets a ton of money. And so legislators' eyes really pop. They're like, ooh, what can we do with the money? And way back when I think John McCain was first talking about it, it was the deficit, because people were worried about the deficit back then. Or we could give it to corporations. Well, we just gave a lot to corporations, but they're still talking about that. Or we could give it back in income tax. Well, what about people who don't have an income tax or don't have an income? So what you do with the revenue is key. Or do you want to give it to government to do research? Or, I mean, there's just tons of ideas of where to put that money. For Citizens Climate Lobby's idea, we want to give the money back to you and you and you and you and you in an equal share. What does that do? Well, basically that makes you invested. That makes you like, wow, I like that carbon dividend I get every month. It also helps you. So what we have is, so there's different kinds of carbon taxes, so you really have to look at them and say, okay, what's doing what? They're not all the same. And then ours would also have border carbon adjustment, because if we're in this country and that country doesn't have a carbon tax, we could be at a disadvantage. So this would put on a price on carbon when it hits the border. Of course, most other countries do have one. So they could tap us, they could hit us with a carbon tax. So this has been studied. There's been a lot of studies coming out recently. I can't even tell you. But credible studies that show, and then this is for ours, just for ours, it would lower emissions 33% in 10 years below 1990 levels. So already that's like 30 years below what it was 30 years ago. And then in 20 years, so this is like still way before 2050, it would lower emissions, just this policy, by 52%. And when you have less air pollution, because people are not using it, their lives are saved. So 227,000 over 20 years. And that's not from like saving lives from not having weather events. That's from the pollution, the air pollution. And then the household dividend would be enough to help people along as they transition to those things are high, food might cost more, whatever. That's a decent chunk of money, $288 a month for a family of 4. Now this is what I was going to talk about earlier, but I didn't. Basically, lowest income people will have a very low carbon footprint, and they would get back more money than they spend in added costs. That's the first quintile to the left of the 73%. So in Montana, that's true too. It was broken down by state. And then the people who are the next 20% of income, 73% of the lowest two quintiles would get back more. 73 would get back more money than they spend in added costs. So really, that dividend would really help people transition. And it would also, though, high income won't have much effect on them. I mean, it'll have a big effect on them, but that's as it should be. That money in their pocket is going to be spent. There'll be 2.1 million jobs in 10 years, 2.8 in 20. There's GDP growth. So let's get to getting it passed. How do we do that? Well, in this model, we would use you. We use you. We use the tools of democracy, which are still open to us. Like, I never walked in the halls of Congress before I got into this group that trained me how to do that. I had heard about this, and then 1 month later, I was in DC. I just loved this model so much. I just like, yeah. And then they trained me, and I went in, and not alone, because you have groups, and you plan, and you get trained, and you tailor it to the person you're talking to, and you form a relationship. And so we're out to get you trained up and happy and getting breakthroughs in your personal and political power. You don't need to know too much about us. We're basically a fabulous organization. But the big thing is number 5. We show respect, appreciation, and gratitude to every single person that we meet with. And we are so bipartisan. We feel like you vote once a year, or I mean every 2 years or 4 years or whatever. What's going to happen in between that? Are you going to wait till the next guy comes in? Whatever. Or are you going to do something now and form a relationship with that legislator and educate them and get them on board by looking at what is important to them? The thing about ours is that it could get passed because there's something for everybody. So conservatives don't like government, or they don't like regulation, or they don't like subsidies. Well, this is not subsidies. This is not regulation. This is a market-based approach. So you just put it in, and everybody gets to decide what they're going to do. Are they going to go buy a big monster truck, or are they going to buy a Prius? Well, I'm not telling you what to do, but you're going to pay more for your gas. That's an objective thing. It's your choice. And so basically, the investors are going to see it, see that price, and make their own decisions. Nobody's telling anybody what to do. But on the other side, it is lowering emissions. There's research to show that it will lower emissions. So we helped start this Climate Solutions Caucus in the House. Did anybody know about that? Great. Right now that was 30. It's 45 Republicans and 45 Democrats working together, getting into a room together and talking about climate solutions. Isn't that a miracle? It's a miracle. And our group has talked to probably all those legislators, and there was one group that got their legislator there was teenagers who convinced them that were trained by Citizens Climate Lobby. Canada, I told you they had just implemented a carbon tax. And Carol LaValle is the woman in the striped. She did 100 letters to the editor herself. This is what one person can do. And got dozens of endorsements from businesses. So it's really pretty exciting what you can do as an individual. And you can, I want to get to other things that you can do. We already talked about talking with people, reducing your own carbon footprint, exercising your political power, and encouraging others. So in that vein, this is a great carbon calculator. And it's on your sheet in the middle of the table is that carbon calculator. It's really neat, and it gives you a lot of ideas of what to do. Okay, so why is CCL supporting a carbon tax instead of cap and trade? Cap and trade is complicated. Cap and trade did not pass Congress in 2009. Cap and trade is unpredictable. You don't know you know what the cap is, but you don't know what the auction price of carbon is going to be from one year to the next. It's all market based. So it's for business. We would with a carbon fee, we'd start at $10 a ton of CO2 emitted, or 15, and then add $10 a ton every year for 10 years. Businesses love it. They know what's going to happen. Cap and trade, you just don't. Like the cap and trade in California, it was $5 a ton. Who cares? You know, it doesn't make anybody say, well, I've got to change my behavior. That's like, so $5 a ton would be like 5 cents on a gallon of gas.
Have you introduced this legislation, or?
So
Or are you
have
with
we
the
introduced
process?
have we introduced this legislation? We are waiting for a Republican to introduce it. We've been massaging and helping all along behind the scenes, because you can't do anything out front, because then they get shut down and, you know, dead in the water. But there are, over the years, there have been about 7 carbon pricing proposals or legislation introduced. A couple of the latest ones are like the Larson bill, which has a really interesting, they all have different, like I told you, they're very different, and like, what do they put the price on? Is it CO2, or is it other things, or what is the rise of your carbon price? So that really does, they're different in each one of those bills. There's one bill that I think is kind of interesting, because it takes a little bit of that money, like 2-3%, and gives it back to like coal communities or communities that are affected. We want to keep it completely revenue neutral, like you give all the money back to the people, because people start fighting. You know, they're like, I want this, I want that. We know that there are communities that are going to need more money to help transition. But to get this bill through, you got to be kind of straight and narrow. Climate Caucus is House of Representatives. In the Senate, there's only 100 people in the Senate, so they have gangs or working groups. But the House has 435 people. You know, you got to get together. And so our caucus, I call it ours, but our caucus actually does, the actual legislators get together 4 times a year, and their staff get together monthly. And they've had people like from the recreation tourism business, they've had national security people come in and talk about the implications of national security. So they are really doing something, and I think they've got some really conservative people on there, and it's still getting their feet under them in a way, but they're saying the word climate. My God, like a couple years ago, they wouldn't even say that word, and if they did, it was in relation to hoax. So it's pretty amazing that there is that kind of at least there's some concern there.
So what's your experience with our Congressman, Greg Gianforte, joining the caucus?
It has not been great, I mean, in actual steps, but we have a great relationship, I think, with his energy aid in DC trip. He loves us. He runs over to see us, and I mean, he allows us to have time with him. And I think and we have actually talked with, if you use the right words and you say, well, this is market-based, and you're interested in accountability, and I mean, it makes them continue the conversation. So I think we need you to help us by writing letters to the editor and signing up over there at our booth and learning more, and the more they hear from you, the more they will do, honestly.
Okay, thank you so much.